All right, so looking at example number 9, 10, and 11. All right, so this is a review at this point, just taking into account everything. So I'm going to do one. This one seems to be from an equation, and this one's from a table. So if you don't remember how to do it from a table, you do need to go to your notes on where there are tables and see how to write the equation. All right, so suppose a scientist is measuring a bacterial population. The initial population of a bacteria is represented by BO. And I'm going to do this as I go. So do remember, once again, we always have y is equal to a, b, x, where a is initial, b is growth or decay, x is time. So it just told me that the initial is BO. So I'm just going to write that. So write the equation that represents the population. So where I have a, I'm going to replace that with BO. All right, I'm just going to do it as I go. Has been doubling every hour. So what does doubling mean? So remember, doubling means multiplying by 2. So that's growth. That goes in the parentheses. So BO, doubling, which is times 2, every hour. So when you're doing doubling, tripling, half-life, sometimes it has two times. So every hour, what does that mean? Every 1 hour. So I can put this as 1 hour. So this is 1 time, and it goes with the word doubling. So if you go back to your notes, that means the one that's doubling, tripling, or half-life goes on the bottom. So that's 1 on the bottom. Create an equation to represent the scenario where T measures the time in hours since the scientist began measuring the population in PT. So PT. All right, so that means the total time is going to be on the top. So I'm just going to write T on the top. So that's the equation. Example 10, suppose the initial population was 100. So now we're just replacing what we already know from my equation. So my initial population, which is going to be B of O, is going to be 100. And then my growth is still 2. All right, and then my doubling time is every hour, so it's still 1. And then the question is, how many hours, so this is still unknown, I don't know that, will the population be 3,200? So this is the question. Okay, how many hours would it be this? Once again, because we just did this question, we can do this by hand, but I am going to go ahead and just make sure that you also know how to do it by calculator. So I'm going to put in the equation and not put in what it's equal to. So just type in A equals B, ABX, and you can put the Y equals if you want to, it doesn't really matter. And then on the top here, T divided by 1. All right, so that's my equation, right? Oh, it doesn't recognize T, right? So that's why it's giving me this error. I can type Y equals, okay. Y equals, oh, it doesn't matter, it took T. All right, so this is what the equation looks like. Now I want to see when is it 3,200. So I can make this a what? A table. And then when is it 3,200? How do I keep going so that I can see additional numbers? I just keep pressing enter. So I'm going to come to the bottom, press enter until I get to 3,200. And what is that? 5. So T is equal to 5. On the other hand, we could solve it by hand, but I just want to make sure that I showed you how to put it in the calculator. Okay, what is the population after 7 hours? Well, I'm right here. So the population at 7, plus 7 hours, T, is 12,800. Explain how you know. Okay, so this is the explanation. I know that it starts off with 100. It doubles every time, and T is 7. So you just got to tell me that's what you typed into the calculator to get 12,800. So that's the explanation, but you can go through the table to just see it. What is the calculator actually doing? It's just typing it in for you. It's taking the equation, you see it right here. There's the equation, and then it's typing where T is 7, it's giving you the number. So this is the explanation on how you know. So what is the population? 12,800. And how do I know? This equation tells me that I know it. All right, so what you're going to do is go ahead and do example 12, 13, and 14. Again, if you don't remember how to do it from a table, please go look at your examples on a table before you do it. Now, I'm just going to make sure that you do know how to use the calculator to just do these without doing it by hand. So all I'm going to do is follow the instructions. So I'm going to do the first one. You do the next two. So it says, type the entire equation into Desmos. Okay, let's go ahead and type the entire question. So 25 raised to the power of 2x plus 4. Uh-oh, what happened? This came down. How do I keep this up there? By using parentheses. So I'm just going to come up here. You put a parenthesis there so that it can stay there. Okay, so you can see it looks exactly the same, right? Equals 625 raised to the power of 2x minus 1. Again, it came down, so be careful. How do I keep it up here? I go back up there and I just put it in a parentheses, and I put it inside the parentheses. So again, just make sure that you've typed in exactly what you see in the question, which I have. This block contains fine detail, does not be fully resolved. Okay, that's fine. It doesn't matter because it's fine. It graphed it. All right, so zoom out if you don't see the graph. I do see the graph, but be careful because it says if you get two different answers, copy the left side on a new line. So let's first see, do I get two different answers? So I am going to still zoom out to see if I have two different answers. What that means is, do I have two different lines? Yes, I do. So you see I have two different answers right here. So this is going to apply to me with the note. Zoom out if you don't see the graph. If you get two different answers, copy the left side on a new line. All right, so what was my left side? This side right here. I'm going to Control C and then Control V. All right, I did that. And then the right side on another new line. So the right side on another new line. Okay, and I'm just going to hide these so that you don't get confused with the black line. All right, then I've done that. Then plug them into the equation where you see an X to see which one works. Okay, so my answer, just so you know, what am I plugging in? Where it crosses the X-axis is the answer. Zoom in, see the value. Where it crosses the X-axis is the answer. So I have two answers in this case. So here's one answer right now, which is 3. So it says type 3 where you see X. We'll put it in parentheses real quick. So 3, that's an answer for that one. And this one, 3. All right, they match. Okay, so then plug them into the equation to see which one works. So this one works. So they match. So this is the answer. So X equals 3, but I'm just going to plug in the other one as well, just to show you that that doesn't work. So let me zoom out to get it. Where is it? All right, there it is. So again, zoom in until you see it. Oh, and we can already tell this doesn't work because look at this decimal. But it's okay. We go zoom in till we get. We can't even see what it is. So there's nothing I can even type in. So I just proved to you that the right-hand side is the one that works. So again, most of the questions, you're not going to get 2 times where it crosses the X-axis. Most of it will be 1. All right. So all you have to do is type it into Desmos where it crosses the X-axis is the answer. So please go ahead and complete these 2 other examples using the Desmos calculator. Let's practice.